Okay, we're going to start graphing tangent. We're going to make a table of values. How do you find the tangent from the coordinate on the unit circle?
X, y over x.
It's the y divided by the x. Good. All right, so let's split this up so that we can get it done more quickly, okay? We have 1, 2, 3, 4, 5, 6. So I'm going to assign each of your groups one of them, okay? All right. So Jesse's group, you're going to do the first one. Meredith's group, you're going to do the second one. Michelle's group, you're going to do the third one, okay? Javaria's group, you're going to do the fourth one. Emma's group, you're going to do the fifth one. Mohammed's group, you're going to do the sixth one, okay? So you need to find the tangent of your angle, please. I'm going to ask anybody in the group, so make sure everybody knows the tangent of your angle. Yes. After you help your group find this, yeah. All right, guys, the tangent is the y over the x. Mabaya, can you give me the first one? Okay, first one is undefined, yes. All right, Alana, did you get the next one? Good. All right, Hunter, did you get the next one?
0.
Good. Yumna, did you get the next one? Good. Renato, did you get the next one? Good. All right, and Griffin, did you get the next one?
-1.
Good. All right, do you guys see a pattern developing? So I have undefined -1, 0, 1, then undefined -1. What do you think's next? 0, good, then 1, and then undefined. And you can double check those on your unit circle, but they are right. All right, so then how do we graph undefined? It's true, like there is an absence of a point there. There's no defined point. The way you show, yeah, very good. The way you show it is with an asymptote, okay? Do you guys remember that word from Algebra 2, asymptote? Yeah. Asymptote, okay? So at -π/2, we're going to make an asymptote. Oops, that's -π/2, yeah. All right, so we graphed undefined at -π/2. We graphed -π/4, -1, 0, 0, π/4, 1. π/2 is undefined again. Do not connect the dots yet. I'm going to show you the way it looks. Okay, then positive 3π/4 is at -1. Pi is at 0. And 5π/4 is at +1, and then we're undefined again. So this function is also periodic. It repeats over and over again, but it keeps getting broken up by these asymptotes. When you sketch it in, here's the behavior of a function in an asymptote. It gets closer and closer to your asymptote without touching it. So it gets infinitely close to your asymptote. Okay, and that happens over and over again. So even though we only made a table of values for these two, we can keep going with more periods if you want. So all I did was I made a table of values from the unit circle, and then I graphed. All right, then there's some follow-up questions here, and I'm going to give you a minute to see which ones you can figure out. Some of them are harder than others, okay? But give it a stab. I want you to try doing these before we go over them. All right, so we got our ranges -∞ to +∞. Michelle, what'd you get? Okay.
1 at the origin and 1 at pi.
Okay. So I got a 0 at 0. And I got pi 0. And I have another one here too, right? So basically all of the multiples of pi, right?
Yep.
So I'm going to say pi times some k. Okay, that means any number times pi, like 1 pi, 2 pi, 3 pi, even negative 1 pi or negative 2 pi. So pi times k if k is an integer. Okay? All right, raise your hand if you have anything else here. Okay, the vertical stretch is the same idea as the amplitude. And remember in sine and cosine, we went up one and we went down one if there was no change in our amplitude. We only talk about amplitude in a sine or cosine function because of its shape. But the vertical stretch works the same as amplitude. So if there's no number in front of the function, what would you guess the vertical stretch is?
1.
1, very good. So the vertical stretch is 1, and that means that when we go from the middle to this point that's halfway to the asymptote, we only go up 1. If I had a 2 in front of it, I would go up 2 there. Okay, that's where your stretch would show up.
Or in a 2 it fell back.
So if I had a stretch of 2, when I went over halfway to my asymptote, I would go up 2 instead of 1. So basically the function would be increasing more quickly. The period of this function is a tricky one. I want to know, and I'll take it in hand in just a minute, but I want to know the length from where it starts and where it ends. And remember that I just want one piece of this graph before it starts repeating itself. Christian, you think you got that? Okay, Christian thinks it's pi. Who thinks it's pi? Raise your hand if you think that it repeats every pi. No one's backing you up. A couple people believe it. Okay. Anybody think it's anything else besides pi?
Oh, wait, no, it's pi over 4.
Okay, and so I have a vote for pi over 4. It's repeating every pi over 4.
I don't know.
Okay, I think you're looking our table. Our table's going up pi over 4, right? But if I just take like a little section from 0 to pi over 4, this piece right here, is that the piece that's repeating over and over?
No.
Okay. So I did hear some votes for pi. Let's see if that makes sense. If I start here and I end here, does that seem like that's one piece?
Yeah.
Okay. And so if I'm going from negative pi over 2 to pi over 2, is that distance a distance of pi?
Yeah.
Yeah. So this is right. It's a period of pi. Okay? So notice that's different from sine and cosine. Sine and cosine have a period of 2 pi. Tangent has a period of pi. Domain. All right, some people tried to start listing the domain. They said, well, from here to here, and here to here, and here to here, and here to here. But it keeps going, right? So I would just have to be listing these periods over and over again until I died. So we do have to leave these numbers out here. Okay, this is good. We're on to something. I'm going to say my domain is all real numbers, except x can't equal what? Tell me some numbers that can't equal. It can't equal negative pi over 2. That's true. What's the next one it can't equal? Can't equal pi over 2. Can't equal 3 pi over 2. What's after that? No, I don't. I'm just trying to figure out the answer with you. And then 5 pi over 2. Okay? So, right, there's a pattern to this, right? It definitely can't equal, I'm going to use the first positive one. It can't equal pi over 2. And then every time I add pi to pi over 2, I'm going to get another asymptote. So I'm going to say x can't equal pi over 2 plus any number of pi's. So that's another pi k, if k is an integer. I get that that's tricky. All right, so I'm going to start back here. Seiji, did you find the cotangent of 0?
0.
Let's see. So we need to take the x over the y. So it's 1 over 0. So what would that be? Very good. Undefined.
Yeah.
Okay. Trisha, did you do pi over 4? 1. Good. Let's see. Javaria, did you do pi over 2? Mm-hmm. All right. Remo, did you do 3 pi over 4? Negative 1. Oyston, did you do pi?
Yeah. Negative or undefined.
Good. All right, Jesse, did you get this one?
Yeah.
1? Okay. Do you guys see that this also follows a pattern?
Yes.
All right, so let's continue. Undefined 1, 0, negative 1. Undefined 1,
0.
0,
Negative 1.
negative 1. Okay. And let's graph. Okay, pi over 4 is in between, and I got 1. All right, and then remember that asymptotes are going to pull the function close, but it's never going to touch the asymptote. Okay, and again, you can continue this pattern. It goes forever in both directions. Okay. So, how is this function different from tangent? It's upside down. Very good. Is there anything else that's different, Danny? Different asymptotes, right. Did you guys notice that? Because it's a common mistake that people forget that tangent and cotangent have different asymptotes. Instead of being on the half pies, they're on the full pies. You see that? All right, so I'm going to ask you to take a minute and see if you can fill in any of these down here. I think that you'll be able to get more this time than you got last time. All right. I'm going to do domain last because that's the trickiest one. Let's start with range. Raise your hand if you think you have the range. I see 1 hand, 2 hands, 3 hands, 4 hands, 5 hands, 6 hands, 7 hands. Very good. All right, Emma, what'd you get? All right, how's that sound, guys? Is that good?
Yep.
Negative infinity to positive infinity. All right, raise your hand if you have the period of this function, how far it goes before it repeats. I have 2 hands, 3 hands, 4 hands, 5 hands. Yumna, what'd you get? Anybody else get pi? All right, very nice. So from here to here is pi. It's a little bit easier to see that the period's pi for this function than the other one. Okay. What's the vertical stretch, guys? Out loud.
1.
The vertical stretch. Well, okay, so I get that this one is a decreasing function, and that's absolutely true. It's a decreasing function instead of an increasing function, but vertical stretch, just like amplitude, is always going to be a positive number.
It's still frozen.
Oh, thank you. So 1. Okay, so then the domain I'm going to do next. The domain, I have 1 hand, 2 hands, 2.5. All right. Did you guys work together on it? So who should I call on? Okay. All right, if you work together, since you're sitting upright, I'm going to call on you, Meredith. Go ahead.
Domain equals all real numbers except x cannot equal pi plus pi over 2k.
Pi. I like the pi part because there's definitely one at pi, right?
Plus
Pi K.
If you because if you add pi to each one, and think about this, could I just express it as also 0 plus pi k, right?
yeah.
So pi plus pi k is right, but 0 plus pi k just simplifies to pi k. So that's kind of, it's nice because it's short. But you're right, you could write pi plus pi k, you could write 2 pi plus pi k, you could write 3 pi plus pi k. All of those things are good. Okay? All right, and then our zeros, we could start listing them. What's the first one?
Pi over 2, 0.
Pi over 2, 0.
And 3 pi over 4, 0.
This one's 3 pi over 2.
Oh, 3 pi over 2.
Okay, so we could list them like that, but also we could write an expression. Did you notice the relationship between the zeros of the tangent, the zeros of the cotangent and the asymptotes of the tangent? Any half pies? But isn't a pi technically a half pi because it's 2 half pies?
Yeah.
So I get what you're saying, but just make sure you're being accurate in your wording,
Like
okay?
2 pies is 2 pies, but like 2 pies is 2 whole pies. And a half pie is like half a pie.
I get what you're saying. I just think that you need to watch the way that you describe it mathematically, but I understand, and I think that your understanding is correct. Okay, so the way we're going to express the zeros is the same way we expressed the asymptotes in the tangent, because where cotangent has a 0, tangent has an asymptote. Why? Where cotangent has a 0, tangent has an asymptote. Why? Beautiful. They're reciprocals of each other. That's right. So the reciprocal of 0 is 1 over 0, which is undefined. So the expression from the for the zeros, I'm going to steal it from over here. The zeros happen at pi over 2 plus pi k. Pi over 2 plus pi k. Good. All right, make sure your neighbors have got everything on their paper, because I know you do. And then we're going to do secant and cosecant. I love secant and cosecant because they make so much sense in relationship to sine and cosine.
Are they easy?
I think so. At first, they may seem complicated, but then they become easy.
Tangent and cotangent is cotangent's always negative.
It's decreasing. It's called decreasing because it's going down. Like they have positive values up here, but it's decreasing. And then your classmates found another difference is that the asymptotes are different. Okay? All right, turn the page. Okay. Cosecant. Cosecant is the reciprocal of what? Sine. Cosecant's the reciprocal of sine. So when we graph cosecant, we start by graphing the helper function, which is sine. Okay. Sine is not a part of the cosecant function, but it helps you find the cosecant function. So use something different to graph sine. For me, I'm going to use the green pen for the sine, and I'm going to use the purple pen for the cosecant. I would say use the lighter one for sine. If you have like a pen and a pencil, use the lighter one for sine. Use the darker one for cosecant. Because sine is not part of the cosecant graph. It just helps you find it. In fact, I think I'm going to use the pencil, because that way you could even erase it. So I'm going to start by graphing sine. Sine starts at 0 and ends at 2 pi. And it goes up, middle, down. So middle, up, middle, down, middle. This is my sine. I could do another period of it as well. Okay, so I graphed in the sine really light. It's a helper function. It's a reciprocal function. And it's going to help me graph the cosecant. Notice there's no table of values here, because there's an easier way to graph cosecant than table of values. All right, cosecant's the reciprocal of sine, and we just said that the reciprocal of 0 is what? Undefined, yeah. So everywhere where the sine has a 0, the cosecant is going to be undefined. So I have undefined everywhere the sine is 0. All right, when the sine is 1, what's the reciprocal of 1? Yeah, it's 1, because it's 1 over 1, right, which is just 1. So this is the same point. And the reciprocal of -1 is 1 over -1, which is -1. So they share these points. All of these points, 1 and -1, they share. And then the way that the reciprocal works, as your sine value gets smaller, the reciprocal gets larger. Think about like 1/4. The reciprocal of 1/4 is 4. 1/10, the reciprocal of 1/10 is 10. So as the sign's getting smaller, the cosecant is getting larger, and it goes up towards the asymptotes. So they kind of look like parabolas, but they're trapped in these asymptotes, so they're not real parabolas. And this one goes down. Okay, so we graph the sign just to help us find the cosecant. The cosecant is in the purple. Once you finish graphing the sign, you could erase it in the middle, because you don't really need it. Just helps you find your graph. Okay, so I'm going to pause for a minute to see if you guys can figure out the answers for these: domain and range, zeros, vertical stretch, and period. The vertical stretch is going to be the same as amplitude on the sign, but again, we only call it amplitude if we're talking about sine or cosine. Okay, here we go. Raise your hand if you want to take a stab at the domain. Nobody can take a stab at the domain. Oyston, do you have the domain?
Yeah.
Okay, quiet down, guys. He's going to share his domain.
I don't have the range.
Okay, I'll take the range in just a minute. All right, take a stab at it, Michelle. Let's.
Okay, is it gonna be all real numbers?
All real numbers.
Okay, all real numbers, and then x does not equal pi plus even.
So pi plus pi k.
Yeah.
Okay, so you could write pi plus pi k because there's one here at pi, and then the next one is pi later. Or if you wrote 0 plus pi k, then it would simplify to pi k, right? Okay, so any of those are fine. I'm going to write pi k because it's the simplest.
Pi does not equal pi k.
X does not equal pi k. Okay, so basically x can't be any multiple of pi. It can't be 1 pi, 2 pi, 3 pi, 4 pi, red pi, blue pi. Can't be any pi. Okay. As long as k is an integer. Did you guys hear that? Because I forgot to mention it. K has to be an integer. All right, range. So Oyston pointed out that our range needs to have two parts to it because we have this piece and then we have this piece. Do you have it, Oyston?
Yeah, okay. Parentheses, negative, infinity, comma, -1 bracket, and then u, bracket 1, comma, parenthesis,
Did I get it?
yeah.
Okay. Raise your hand if you had this as well for your range. Anybody have the same thing? Okay, so 2 people had this as their range. Raise your hand if you have a question on this range.
Is it,
Go ahead.
is it allowed to be more than,
One piece?
yeah?
Yeah. So basically there's a break in your range. Your range starts at the bottom where these arrows are going, and that's negative infinity. And it goes up to -1. And then there's nothing for your cosecant in the middle. That was just the sine part there. Then your cosecant starts up again at 1 and it goes to infinity. What are the zeros for this function?
It's always numbers, right?
Yeah. What are the zeros, guys? None. There are no zeros because it never touches the x-axis.
Wait,
The vertical stretch is still 1 because we didn't stretch the function. And the period is going to be up for debate. I am expecting you guys to tell me one of 2 different answers, but only one of them is right, so we have to figure it out as a team. What's one of the answers? One of the answers is pi. What's the other answer? 2 pi. So we have to figure out, does it repeat every pi? Is it the same thing every pi? Or do you need to go 2 pi before you have a pattern that repeats?
No, but it's negative.
Right. So the pattern is not just up. It's not up, 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 up. So every time we go 2 pi, you can go 2 pi to the left or you can go 2 pi to the right, but every time you go 2 pi, you have a full cycle. So the full cycle is the up branch, and the down branch. So the period here is 2 pi.
And it's because you need, that's how far you need to go to see a repeating pattern.
Very well said. Okay, so Jesse said that's how far you have to go to see a repeating pattern. You need the up branch, you need the down branch, then you start over. Up branch, down branch, start over. All right, secant. What do you think we're going to graph to help us graph secant?
Cosine.
Cosine, very good. So we're going to graph cosine. Start by graphing cosine. Go ahead and do it. Again, you want your cosine to be light. So 1, 0, -1, 0, 1. All right, see if your neighbor needs any help graphing cosine.
So we just start one of those. So
Yep, cosine starts up, middle, down, middle, up, and then continue. We're going to look at more than one period this way. I understand it's kind of light. It's light on purpose, but here's where it goes. Up, middle, down, middle, up. Okay, where am I going to have an asymptote? Well, the reciprocal of 0 is undefined, so I'm looking for the zeros of the cosine. Where's the first one?
5 or 2.
Yep. So right here, the cosine 0, that means the secant's undefined. So I'm going to draw an asymptote. Where's the next one?
3, 5 or 2.
3 pi over 2. Okay, so everywhere the cosine has a 0, the secant is undefined. So then you're going to take the points, and they share the same point, and then you're basically flipping the curves. Okay? So this one was open up, so that means your secant's going to open down.
Yes.
Okay? And if you end up with these half pieces over here, you can draw a half piece if you want. Or you could continue over here and draw another asymptote and then fill in the other half. It's up to you. Okay. So take a minute to fill in the bottom and compare with your neighbors. By now, I think you guys are getting this. A lot of you are getting the whole bottom. Okay, this domain is the same domain as which function? Look back in your notes. It's the same as which one? Tangent. Yeah, it's the same as tangent. So if you look, it has the same asymptotes as the tangent. Pi over 2, 3 pi over 2. So this is going to be your same domain. X does not equal pi over 2 plus pi k. K is an integer. Okay, raise your hand if you have the range. Michael.
It's negative infinity to negative 1.
Good.
And actually, yeah. Would it be that or would it be because the very first? Okay.
Wait one sec.
And then,
Wait a sec.
And then positive 1 to positive 9.
Right. Okay, so this part in the middle is just cosine. It had nothing to do with the graph, so you had to stop your graph at -1 and then pick it up again at 1. How many zeros are there? None. And there's no vertical stretch, so I just put what number?
1.
Okay, and the period? 2 pi.
Miss Brown,
Yeah.
could you simplify on the domain to pi over 2?